Good morning, Shri.
Hmm, 1 minute. Joining.
Yeah, hi, morning, Sri.
Morning. Just checking the sync out 1 minute. Okay, and we'll start. So we discussed about the stored procedure, right? The stored procedures, and we also discussed about some part of window functions, correct?
Yes, Shri.
Okay. Yeah, we'll start, as I mentioned, we'll start Snowflake today. So, any challenges while executing these window functions and stored procedures? Have anyone? Any specific questions on the window functions and the stored procedures? Meena, Venkat.
Uh, I am still at the initial part,
Okay.
Srini.
So, yeah,
So I have few doubts, but I'll have them after a call, end of the call. Or
okay, no problem. So, but if any specific questions you have, just reach out to me, okay?
yeah, sure.
Yeah, today let us start and discuss a little bit about the Snowflake roles. So, Snowflake, we discussed about Snowflake environment and Snowflake fundamentals and all, but we after that we started SQL for some time and we discussed about the SQL part. But when I talk about Snowflake, let me share my screen. So I hope everybody have some fundamental idea on what is data warehousing. So I'll explain once again what is data warehousing and I'll jump into the Snowflake part. Just a minute. If you are able to see my screen. Okay. Okay, you're able to see my screen. So when I talk
Yes.
about data warehousing, so Snowflake is also one of the cloud data warehouse or database you can call it as. So we can build a data warehouse by using Snowflake, and there are so many different ways to create a data warehouse in the market. There are so many tools available. But what is the data warehouse? A data warehouse is a database only. So which will summarize your data and which will have the raw data as well as like what the data you are summarized. That also historical data. So the historical data will be stored in a data warehouse, which is also a database. But how the data will come into data warehouse? We have multiple different sources here. So each and every source will come from multiple different locations, and it may come from directly from flat files. Some part of data will come from the real-time operational systems. So, but all this data will be integrated and combined and pushed into the data warehouse, and that can be utilized by most of the end users. So, users will be like so many people will utilize this data. They will use for reporting, and some people use for data mining, and some people use for machine learning and data science. Some part of the data will be used for dashboard development. So, most of the data in the data warehouse is a final golden source which will be utilized for building the end user requirement. But the data warehouse, whatever we saw earlier, most of the data warehouse will be on the database only. But nowadays, if you see, a data warehouse is also people calling it as a big data warehouse also. If the data volume is high and with different varieties and with high velocity, then we call that as a big data warehouse. And also the same data warehouse is also capturing live streaming data, then we call that as a data lake also. So all these are like the new terminology, and we can see how the market is, our industry is trying to migrate to this particular data warehouse to big data warehouse and big data warehouse to big data lake. So there are so many frameworks available in the big data side also. We can talk about Spark is one of the in-memory computing engine to process the data, that is huge amount of data to like build a big data warehouse, and HDFS to store the data in the distributed file systems. So coming to like data warehouse is basically, if you go to normal traditional data warehouse, there are so many challenges nowadays. So when people were trying to think about the like data, separate the data into separate database and call that as data warehouse, that time people were not worried about some of the challenges like scalability. People are only worried about how to separate the data historically. When when scalability came into picture, there was a big challenge. It's not easy to scale up a data warehouse, and OLTP processing is not suitable for data warehouses, and no distributed processing, no concurrency, and a single point of failure also. So whenever data warehouse is down, all the connected applications will be down. So whenever you talk about cloud data warehouses, so on-demand scalability will be there. So scalability means what? We will add additional machines. That is very easy in cloud data warehouses. It's very easy in Snowflake to add new machines or clusters to the Snowflake virtual warehouses, which are the part of compute. Compute means here a compute is nothing but a group of machines that will provide resources like CPU, temporary storage, memory, all this to run the SQL statements. So here on-demand scalability is very easy, and OLAP, column oriented database, and concurrency and distributed work is possible, and no single point of failure, and zero overhead and maintenance. So infrastructure wise, if you see, the maintenance will be zero. Most of the data warehousing projects nowadays are running on the cloud because the users want to eliminate the infrastructure burden. So cloud data warehouses will help you to reduce the like uh, maintenance cost, like infrastructure cost also. So that is where companies are getting attracted with the AWS cloud or Azure cloud or Snowflake, these kind of environments. And apart from this, we also can build data warehouses on most of the databases such as SQL Server, Oracle, Postgres, MySQL, all these databases. So all this will be helpful to build the traditional data warehouses. But whenever you come and see about cloud data warehouses, we need to depend upon either Snowflake or Redshift from AWS cloud or BigQuery from GCP, or we also have Cosmos DB is there. We also have DynamoDB. There are so many different databases available in the cloud to build the cloud data warehouse. So the difference between traditional data warehouse and cloud data warehouse is the normal traditional data warehouse will be on the on-premise physical server. So we need to worry about infrastructure and so many things. But when you come and see for cloud data warehouses, you do not need to worry about infrastructure. You only need to worry about the compute cost and if any storage cost is involved. And apart from this data warehouse, we also need to think about what are the different ways to build the data warehouse or data lake in the cloud. That is what majorly as a data engineer nowadays companies are expecting. So when I talk about data warehouse in the cloud, we need to know most of these activities, so such as data modeling. So data modeling is nothing but how to create the group of tables and how to go and create the physical data model with multiple different tables involved and identifying them and create a relation, and we need to build the physical data model and then create the tables, and then those tables should be loaded according to the data warehouse like which we are going to use, and optimizing the queries. So whenever you go and do the data modeling, definitely you do the data modeling on the database if it is structured. So whenever you are running any SQL queries, there is no like restriction that the queries will run fast every time. The queries may sometimes go and run slow also. The performance may go down because of some of the ideal scenarios such as the scalability is not up to the mark and the number of resources are not sufficient. In such scenarios, you should know how to optimize the queries. And billing and cost management also need to look into. So it doesn't mean that I am using a data warehouse and I can keep on increasing the capacity. You also need to see how to manage the billing and cost also. And the user access management also is important to give and provide the only authorized people to access the data. And finally, it should be enabled for the business intelligence and analytics for the decision making also, like building the dashboards and all. And along with all this, we also need to think about data governance and security also for the data. So data governance and security in the sense how you are trying to mask your data, how you are masking your data, and how it is getting like restricted from the unauthorized people, and any sensitive data is there, how to go and restrict that particular part from the unauthorized users. And security wise, you should have the proper authentication and multi-factor authentication and database protection, all this. So Snowflake basically will have all these features. And second thing is ETL movement or ETL management. How to write the efficient pipelines by using most of the languages such as Scala, Java, and Python. But here we do not need to worry about all this. In Snowflake, we can write some of the stored procedures using these languages like Scala, Java, and Python, but data pipelines we can build using the normal SQL commands. And orchestration. So orchestration is also important when you are building a data pipeline. So because most of the orchestrations nowadays, people are performing on that particular cloud tool itself. If you go and see step functions is a part of AWS environment. When I talk about Airflow, which is a open source, that is also a Python package which can be used for orchestration of jobs nowadays. And the deployment and integration and ML model development. All this also nowadays became part of the ETL jobs. And once after you build all these pipelines and all, how can we go and build some of the like a best solutions for deploying the scalable pipelines. And finally, you also need to know how to log and alert and send the notifications if any pipeline will failure. So all these are part of any data warehouse nowadays. So as a cloud database. So Snowflake also will have all these features which can be managed. So when I talk about Snowflake, we discussed about some of the features which you remember, I think. The first and foremost thing is Snowflake is a complete SQL database. And second thing, zero management. And third one, all your data is centralized in one location and will be accessible by multiple users using multiple devices at any time. And all of your users, so every user, I can manage any amount of data, any amount of workload at any number of users. That's what we discussed about. There is no restriction on the number of users or the amount of data. And finally, pay only for what you are going to use. Pay as you go, like our postpaid. So all these five unique features making Snowflake as a leader in the cloud data warehousing side. And apart from this, Snowflake also provides some of the features such as shared nothing architecture. So what is a shared disk architecture? And any idea? What is a shared disk architecture? Anyone? If you know, Arun, any idea what is shared disk architecture? By any chance?
Shared disk,
Yes.
shared disk architecture is basically like centralizing a disk somewhere in server or something like that. Like all the
Correct.
nodes will be accessing to that particular.
Exactly. You are right. So the shared disk is nothing but one single storage disk will be there, which will be accessed by multiple machines. Normal traditional databases like Oracle, SQL Server, all this will follow shared disk only. There are some challenges while using shared disk because if this particular disk is down, all this will be down, right? Yes or no? Do you agree?
Yes,
Which means that this is not the right choice of building a data warehouse always. You should have a shared nothing architecture like this. The modern databases which are now available in the market are following shared nothing architecture because every machine will have its own storage and even they are connected. Assume suddenly if any one mission is down, other missions will be available for data availability. So that is where most of the modern databases are running. So your downtime will be reduced. At the same time, since you are adding additional storage here, you will have some storage cost also, but you will not have like downtime like the shared disk architecture. Snowflake here will follow a combination of hybrid architecture, which is a multi-cluster shared data centralized scale-out architecture. So centralized scale-out means scale-out is nothing but how you are going to increase the size if needed, or increase the capacity or number of clusters if needed. So this architecture is a unique architecture and which Snowflake is following with multiple independent compute clusters also. So multiple independent compute clusters means you will have a multiple group of clusters in the Snowflake virtual warehouses. A virtual warehouse, we'll discuss about that, is a group of clusters, and each cluster is a group of machines. So we can create a virtual warehouse in Snowflake environment. One or more virtual warehouse you can create, but each and every warehouse will have a group of clusters here. We can create a single cluster warehouse or multi-cluster warehouse also. So based on your choice of your demand, you can create the multi-cluster warehouse also if needed. And this is which architecture which we discussed already. Snowflake follows three-layer architecture. The first one is cloud services architecture, that of most one. And second one, compute layer. First one is cloud services layer, second one compute layer, third one storage layer. So if you see here, the first layer, the topmost layer, that is the cloud services layer, which is going to allow us to authenticate, like login and login to pass into Snowflake environment, you collect through cloud services layer only. And this layer is responsible for authentication, metadata management, and also infrastructure management and security. So whenever I'm going login, sometimes I also need to use some of the multi-factor authentication also, and transaction management and optimization. Most of these particular activities will be done in the cloud services layer. And the second layer, what do you see? This is the actual development layer. We use compute here, which is called virtual warehouse, and this is also called as virtual warehouse or compute layer also. There are so many different names. Or query processing layer, people will call it as. So because all your SQL queries will be executed in this particular layer only. And while running the SQL queries, we definitely need a virtual warehouse also, mandatory here. Without a virtual warehouse, I cannot run any SQL statements in Snowflake environment. And you need to have a virtual warehouse to run the SQL queries in this environment. And finally, centralized storage layer is nothing but the storage area where Snowflake will maintain our data. And this layer will be in the AWS cloud or GCP cloud or Azure cloud based on the cloud we selected while creating the Snowflake account. So it can be S3 bucket if it is a S3 AWS environment which we selected. And if we select the Azure, it will become a blob storage. And if I would have selected GCP, then it will become the Google Cloud Storage. So this three-layer architecture is very, very important to understand by every Snowflake developer. Any questions on this, like three-layer architecture by any chance? Are you guys able to understand what is the three-layer architecture? Cloud services layer, compute layer, and third one, storage layer. Okay. Now, we discussed about very basic level of features which Snowflake is offering. There are so many other features where Snowflake is becoming unique here. The first and foremost thing is, which we discussed just now, the architecture. The architecture is a like a multi-cluster shared data architecture where the data is stored in S3 and which will allow multiple EC2 compute clusters to access the data simultaneously without any contention. So data will be stored in S3 bucket and compute clusters will be maintained by EC2 instances. I hope everybody know what is the EC2 instance. A EC2 instance is a virtual server which can be created in the AWS environment. One EC2 instance will be one machine. So like that, the EC2 compute clusters means EC2 machines. A group of EC2 machines will be used for processing the SQL queries. And then data types. So Snowflake supports multiple different data types along with normal traditional data types. Like it will also allow like JSON data, XML, Avro, Parquet. Yeah, it will also support like ORC, all this kind of data where you can go and directly ingest without any transformation. We do not need to convert them into any form. Directly we can load the data into Snowflake environment, and then we do some transformation also later. And the scalability which I was talking about, data is not combined or coupled with the compute here. Like we go to traditional databases, so data and also compute are coupled. So whenever you increase the data size, like upgrading the hard disk, you need to stop the server, and you will definitely will experience some downtime. But in Snowflake, the scalability is instant. I can easily increase the size of the warehouse or add additional clusters to the warehouse very easily without stopping the queries also. So that is how like scalability is going to help us in Snowflake environment. And concurrency. So concurrency means where I can go and parallelly execute multiple queries, and where I can easily go and experience the auto scaling feature to allocate the resources if needed by any query. This can be usually we can increase, but Snowflake will automatically increase the a warehouse number of clusters based on the query requirement. We do not need to worry about that. Snowflake is intelligent enough to allocate the compute resources if needed. And administration is zero. No hardware or software is required to install or manage here. We just need to log in and use it. No need to maintain any infrastructure also from our side. No IT involvement is needed here. And the support, you will get 24/7 technical support plus ecosystem. So ecosystem means which tools I can connect with Snowflake. There are so many tools available to connect, and which are authorized to connect to Snowflake environment. So different tools available in the market like Power BI connector, Python Snowflake connector, Tableau connector. We also have like a ClickView connector and Snowpark connector and Alteryx integration we can do. So there are so many tools available in the market which can be easily integrated with Snowflake and manage the Snowflake data also. The newly invented tools such as like DBT, Matillion, Stream Sets, and CoolCTL, Thirtran, many different tools available, and they can be easily connected or integrated with Snowflake to perform the transformations on the Snowflake data. And apart from this, all these are additional features which Snowflake is providing compared to other cloud databases. JSON data we can load without any transformation, or XML data or any kind of data. Normal traditional databases, if you see, we need to store the data first and then we need to use it. Or we need to convert this JSON data into a structured form, and I need to load into a table and I can use it. But in Snowflake, it is not mandatory to convert the data into a form. I can directly load the JSON data into a type of column called variant column. Variant is a data type in Snowflake which can store any kind of data. So if it is a JSON document, I can directly load into that particular data type. Even in Parquet data also, or XML data also. And apart from that, we also have a unique feature called cloning. So cloning is one of the feature which is also called as zero copy cloning also. This feature will allow you to create a instant development test environments, and which we can be used for your actual development and testing. So without any additional storage. So that is the benefit with cloning. So when you are cloning a database, production database to a development database, in general, if my production database is 2 terabytes, my development also will consume 2 more terabytes. In total, I need to have 4 terabytes storage. And if there is no data storage available, you have to buy also. But here in Snowflake, whenever you clone any database to a new database, there will be no storage cost for cloned databases. So that you have to remember. A clone database will not have any charge. It will not consume any additional space in Snowflake environment. Only normal traditional databases which contain certain amount of data need to pay for storage cost. So we'll discuss about what is storage cost, compute cost, and data transfer cost, all this. But till the time, please keep in mind, Snowflake will charge the customer for compute cost, storage cost, data transfer cost mainly. So when you store the data, you need to pay for that in Snowflake environment. And time travel is another feature, unique feature available in Snowflake to restore your data whenever you deleted it permanently. So time travel will allow you to travel back to a particular point of time, and then I can see what data was there during that time. And this time travel period also we have up to 90 days. After 90 days, it will be automatically moved to a fail-safe period. So fail-safe period is not under our control. So if the data is in fail-safe period means your control will be automatically transferred to Snowflake team. So you need to reach out them to get the data. In normal relational databases, assume a scenario, you have some set of tables, maybe assume a customer table, very sensitive data, and you accidentally deleted some data from the table, and you later realize that that is a sensitive data, and you want to restore it. Can we restore already deleted and then committed data from the database by any chance in normal traditional databases? Can we do that? Once you remove the data, can we restore the data? My question. Yes or no? No, we
No.
cannot. Because once you delete or drop the table also, I cannot get it back. But in Snowflake, I can get it. Even my data is permanently deleted, and I committed the changes also. How normal traditional database will not provide. The same thing can be achieved through Snowflake by simply using the time travel feature. Assume 1 week back I deleted, so I'll go back to 1 week and I'll see what data was there before I deleted, and then I'll restore that data. So it will be available up to 90 days, the maximum. We cannot go beyond that. Okay. And query caching is another important feature which will allow you to use the query results up to 24 hours. So what Snowflake will do, any query you execute in Snowflake environment, the query results will be stored in the query cache for up to 24 hours. So query cache will help you to reduce the warehouse utilization, and up to 24 hours I can use query cache and get the results. So no need, so you will not have any additional compute cost here. So query caching will reduce your compute cost by avoiding using the virtual warehouses. And backup, so automatic cross region data center replication will be taken care by Snowflake team with the help of AWS. We do not even need to worry about how the data will be replicated in Snowflake. That is not our job. That is the responsibility of the Snowflake team. They will take care of the weekly system updates and backups, all this stuff. And that too automatically without any downtime. And data sharing is another feature which is very famous in Snowflake. To share the data between multiple Snowflake accounts. I want to share my data with you, and we both are not from the same account, and both are in same region, for example, so I can share the data. So secure data sharing is going to allow you to share the data with other Snowflake and non-Snowflake accounts with secure data shares. So that we'll discuss about once you go to secure data sharing. And auto scaling will be done by Snowflake automatically whenever there is a demand for the additional clusters. And the data is centered in one location will be accessed by multiple people from the multiple regions. And the data will be automatically encrypted by default, and whatever the data we are storing in Snowflake is automatically like compressed. We don't need to compress the data. And apart from this, you also need to understand about the Snowflake is a pure elastic instant data warehouse which will provide multiple resources that too on the hourly basis they will charge us. So based on the amount of credits you are going to consume, and storage is separate and compute is separate in Snowflake. So no need to worry about when you are increasing the storage means it will not impact the compute. Same time when you are increasing the compute, it will not impact the storage. And that's about Snowflake, very basic level of uh, features and all which we discussed about. And I hope you people created your Snowflake account, right? All of you. Did you created your Snowflake accounts?
Yeah, yes, I have created.
120 days account, correct, right?
No, I didn't create it. Srini, I will create today.
Okay. You know, right, how to create it. There is a document for this, the 120 days account document. So you need to follow that.
Okay.
Okay.
Okay. I will check that document. If not found, I will
No,
ping
this
you.
won't take much time. Let me show you. Maybe it won't take much time. It's 1 minute we can create. You can follow that. That link you need to find out. The link is important here. When I'm creating a Snowflake account, for example, let me show you. So if you go here, you need to search for student link. signup.snowflake.com/?trial equal to student you have to mention. This link is important. Okay. So when you select this link, this will be redirected to 120 days account only. If you go to normal traditional Snowflake environment, it will show you only 30 days account. Hope you are getting what I'm trying to say. You go to normal, let me show you. Directly go to Google and search for Snowflake free trial. When you click this, see what it will show. It will show you a 30 days account. See? So after 1 month, again, I need to create a new account. So Snowflake never restricts you to create multiple accounts on the same email. So here, a 30 days account only is available in the Snowflake website. If at all I want to create a 4 months account, then I need to use the one which I was talking about, this one. So you need to use this link, okay? Arun, you need to use this account, this
Oh,
link.
okay. Yeah. Okay. Yeah.
I'll just ping you in the chat and just keep it handy. That will be easy for you. Simply follow the instructions, okay? And it will create you a 120 days account. So I'll try to create one account now and I'll show you. You can follow the same, everyone, if you have not created. I hope others you created already. Correct, right? Meena and
I
Shekhar.
have not created yet, Srini. I will
Okay.
create.
Just follow these instructions, whatever I'm
Yep.
showing. Okay. So just to keep that link handy in a notepad and try to open that. You can do now if you have a like option to do this. So just to go and enter your details here. You need to enter your first name, last name, and your email, and you can enter any details here. There is no restriction. Correct details you need to enter, and then click on continue. And here you need to select one Snowflake edition. So try to select only enterprise as of now. I'll discuss about what are these editions and all this stuff in the next class with Snowflake pricing. So just select enterprise, and then while selecting the cloud, select AWS for now.
Okay.
And then
Country UK is fine, huh?
I'm sorry.
Okay. Country you selected UK, right? Like
No,
that's
that will
fine. Or
automatically
India.
select based on your
Oh.
laptop configuration and all. So,
Okay. Okay.
so
Okay then.
you can select anything. If you select AWS, whatever it is showing you, keep it as default. Then check this checkbox. Then get started. So it will ask for some of the security check and all. If it asks you, just do that. Next. What is this? So it will move to this page. Keep everything. Don't need to select anything. That's it. Your account is ready. So you need to go to your email. There you might have received one activation email. So once you go here to your Gmail, in your Gmail, you will see one activation email. So that particular email, see, you will receive this email. Can you see, everyone? You might have received one email. Just try to click on that activation email, and in the down you will see one activate button and one URL. So keep it URL handy. Copy this URL and store somewhere in Notepad, because you need to use this URL going forward to login. So once you click on this activate button, this will open the same URL, whatever we just saw, and it will prompt you to enter your username and password. Try to enter the default username which we use. In general, whatever you can remember easily, you can use it. Okay. Username should be a unique username, and then click on get started. Then this will be redirected to the Snowsite web interface. Whatever you see here, this is called as Snowsite interface. Venkat, you created, right, this account?
Yeah, Sri.
Okay, cool, very good. So now you will become an account admin by default, because this is your personal account. In going to enterprise level, you will not be account admin. You will receive the role on how to access this environment in general. But as of now, you can see you are an account admin. Okay, because this is your own account. In normal scenarios, you will not be account admin. There will be one more account admin who will give you access. Now you can see most of the roles here. These are called roles. So all these will be called as system roles. So sandbox role. Only it is showing. I don't know what it is. We will see that. Okay, we will see. We got $400 credit for free of cost, and you can go and see like account admin you can select here. So how to run the SQL queries? Directly go to the projects, and here you will see some sample queries are there. We can go and select and see and run some sample queries, like 10 terabytes data is there. So 10 terabyte data, I can go and simply run some of the SQL queries also like this. So I can create a warehouse, and then I can go and directly use some of the complex SQL queries also and execute them. So we can test it, because most of the tables here, whatever you see, store sales, this kind of tables are very huge table. So if you go and see, the database tables are in very huge size here. So if you see store sales, store returns is 933 GB, and store sales is 10 terabytes. So if you want to experience huge amount of data and want to work on huge amount of data, use these tables always. And you can test Snowflake environment by running some of the sample queries also. So how fast it will execute the queries based on the warehouse size, it will execute. So we need to have the decent warehouse size here. As of now, the warehouse size, whatever you see, that is not visible here. Okay. Just refresh this. So I should see a compute warehouse available to run my SQL queries. So let me try to.
Is this a sample data like which you're showing now?
Yes, I'm coming to that. So whatever you see, most of these are queries on the sample data only. To test the Snowflake environment, they gave
Means
you.
which is available in already Snowflake.
Yes, yes, by default. For every user, you will see. So you are able to see the same
Okay.
thing, right? You
Okay.
also you also can see the same thing, right? From your side, I'm asking.
No. No, I didn't created it. Like
Okay, once you
I'm just
create, you
creating.
will see the same thing. That's
Yeah.
what. Okay.
Okay.
So just go and open a worksheet here. In the worksheet, you will see the account admin role and then the compute warehouse. Okay. Here you need to start working, creating the databases and tables, all this stuff. So you can do anything here. And you whatever database you create, you should see the left hand side here in the list. Here, assume I want to get a database. I'll simply go here and I'll see. I want to create ingest data. I simply executed this and you will see a database got created here. See? Yes or no? It's very easy to create the database here. And I can create a table also. So to create a table, now database is not selected. I'll select the ingest data public schema. So public schema is by default will be created. If I create a database, by default these two schemas will be created, information schema and public. So here I select the public schema and ingest a database. So the table whatever I'm going to create will be created under this particular database only, ingest data going forward.
So it is not a warehouse here. It is a database. Like,
Correct. This is a database only. We can create a data warehouse using this database.
okay.
Okay. So here I will just create a table and this table will be created under which database? Ingest data database public schema. When we run this, you should see a table now in the public schema. See how we created in SQL Server, right? Same like that I can create here also. How you inserted the data, I can insert using insert statement, delete statement, update statement. I can follow the same here because even Snowflake also follows ANSI SQL. Hope it is clear. Okay. So I'll share some sample SQL statements or SQL scripts which you can work on, and you need to create today the Snowflake account, and in the Snowflake account you need to create some of the sample databases and sample tables. So I will share some scripts, sample scripts which you can go and try to run in this particular environment. And I also share this PPT and some of the initial documentation on what is data warehouse and some of the ATL foundation kind of materials. You can go through it. Okay, everyone? Yes, sir. No?
Okay. Yeah.
Any specific question from anyone?
Srini, like
Hmm.
I've asked couple of times like difference between database and data warehouse and this one. Another one is data lake.
So
So how to
data lake is also data warehouse with
uh
live data always. Data warehouse will have
live
only
data.
data warehouse will have only historical data, right? No live
Okay.
data. If I am able to capture live streaming data, then I call it as a data lake always.
Okay.
So
Okay.
database, see data lake also or data warehouse also is database only. Correct, right? The terminology is different.
Yeah. Yeah.
How we are going to
Yeah.
access it is different. So a data warehouse also a database with historical data. And data lake also we can call it as a database with historical data plus live streaming data together. Simple. If you have a big data, huge amount of data, then the same data warehouse will become big data warehouse and data lake will become big data lake. Simple. The difference will come only if your volume is high and you have a different varieties of data, then only we call it as a big data. If I'm only capturing structured data, we call simply it as a data lake or data warehouse. If any other types of data is coming into picture, then we call that as a data big data lake or big data warehouse. So nowadays, every data warehouse is a big data warehouse only because of data volume. Earlier, it was not that much data available, right? So people never used to worry about big data. As soon as big data came into picture, everybody started building the big data warehouse or big data lake only. Nobody is trying to build a normal traditional data warehouse. Hope it is clear.
So here, Srini, we have like live streaming
Hmm.
data. Like, can we
Hmm.
create? How to create that everything?
Streaming data and all we cannot directly create here. We need to integrate with the streaming engine framework called Kafka. But as of
Okay.
now, we'll try to learn about how to perform the bulk loading and continuous loading by using Snowflake environment. And streaming is basically will be captured from the other services as I mentioned like Kafka or Flink, and that is totally different approach. We'll see that later. Okay.
Okay. And data warehouse, it
Hmm.
was told like it is a historical data.
Correct, correct. Which will capture
So,
the historical data. That is a data warehouse. Only historical
okay.
data.
Historical data means it is old
Old,
data or
old
which
data
is
only.
already.
Past data.
Okay.
Not
In database also we have past data.
correct. Past data. Sometimes what happens? Daily transactions also will be there, right? In the data.
Yes.
Then it is not a data warehouse, right? If your database contains daily transactions, then that is a real-time data, right? Real-time.
Yes.
If I don't have a real-time environment and I want to separate that into a separate database, that is data warehouse.
Okay.
That is usually we call it as a data warehouse to manage the historical data and use that for analysis. Simple.
Okay. So which is like which cannot be changed and cannot be added new things.
Correct. A data warehouse usually will not change, right? Because the
Yeah.
analysis will deviate. So people will never change data warehouse, but data like real-time data environment will change. That is quite common because
Okay.
because real-time data, right? It will be changing frequently, most frequently.
Mm. Yes.
It is not suitable for analysis. That is the reason we created a data warehouse separately.
Okay. Let's say I have few jobs and they are
Mm.
executing daily,
Mm.
and there is data changes daily. So
Mm.
how can we implement that in using Snowflake? Do we need to create database and
See, Snowflake is suitable for both data warehouse. I can even create a data lake also. Then I need to get a data lake, right? Real-time data capturing is involved. I need to use a data lake, not data warehouse. So my data lake will be capable to capture both, right? Historical data
okay.
plus live streaming data. So in such
Mhm.
scenarios, I need to build a data lake, not data warehouse. Simple.
Okay. So not database?
See, all data lake, again, data warehouse, all these databases only.
Okay.
So there is no much difference. The terminology is different, that's it.
Okay.
Yeah, yeah. Okay, I'll share
So
some
how can
documentation.
we
You can go
have
to it. Yeah.
okay, how can we have real time connection with how the data
Hmm.
real time data loads if I have few jobs and few programs?
We need to create a data pipeline. Huh? So we need to
Okay.
integrate with, for example, Kinesis or Kafka first and extract the data and convert that into structured form, and then we need to load into the Snowflake environment.
Yeah.
That is a different area. Okay.
Okay.
So that we need some time to understand. First, we need to understand the fundamentals. Then we'll go and try to see what is bulk loading, and then we'll discuss about continuous loading. In the continuous loading part, we'll see about how to go and capture live streaming data and store.
Okay.
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 Yeah.
Shri, what is meant by cluster?
A cluster is a group of machines.
Oh, yeah, okay.
So a group of nodes we call it as. Okay.
Yeah.
Just
Mm,
good.
Just a small question like
Uh,
flat files means like
CSV files,
those
CSV files,
CSV files, yeah,
Excel
JSON
files,
files.
uh,
All.
uh, JSON files will be fall under semi-structured data.
Structure. Okay.
CSV is a structured format, rows and columns. So wherever
Yeah.
you see rows and columns, all those will be called as
Structured data.
structured data. Correct. Tables, database
CSV
tables,
files,
for example.
TSV files, all of them, right?
Correct.
Yeah.
JSON, Parquet, Avro, ORC, XML, all this called as semi-structured data. Any documents, videos will fall under unstructured data. Simple. But
Yeah.
yeah, unstructured data also you can process in Snowflake. For that, I need to use a document AI. But we are not, no need to worry about that particular unstructured data. We need to see how to load structured and semi-structured both. Okay.
Yeah. Yes.
Okay then. So I'll share these documents. Please refer them and try to work on some of the sample SQL scripts which I'm going to share, and we'll try to discuss about the Snowflake roles in the next class. Okay.
Yes.
Okay then. Otherwise,
Thank you.
no problem.